I'm here today to take it to a slightly different direction and talk about something that we've worked on for a while on the application side. And love to kind of share that journey with everyone. So again, really quickly, my name is Grace Huang. I lead a team of scientists and engineers at Netflix, and we focus on working on algorithms that help personalize member outreach, on growth, and some of the art and marketing algorithms. And so what I'll do today is to take everyone through a journey of how we think through a specific personalization product that we've created in the past. So if you're like me, living in the US, in the Bay Area, you probably spent the past few months at home, a lot of time at home. And if you're like me, at the end of the day, I just want to sink down my couch and turn on my TV and enjoy something like a show. So at Netflix, our mission is to provide really relevant and compelling stories to delight our members. We want to spark joy. And there are a number of different ways to do it. Obviously, the first way to do it is to create really, really compelling content so that we can share that with our members. Another way to do it is actually to work on a personalized product such that we can personalize every single member's experience and tailor our recommendations and outreach to our member to the specific member that we really value. And so as part of that, if we create better content, we firmly believe that our members will enjoy our service more. And similar to that, we believe that if we improve our personalization of the various in-app as well as out-of-app experience, we're able to make more relevant recommendations to our users, and our members will be able to find relevant content to enjoy. So that's really the core of the personalization product that we're talking about today, which is that we want to create a system where we have a way to reach out to our members effectively with different channels. And we want to be able to deliver useful engagement messages like, hey, here is some interesting product and content that you might enjoy, as well as important information like someone's accounts, payments, and a lot of important notifications for the users. And so there are a few different ways we can reach out to our users. We have emails, and so in the body of the email, we might have a lot of different types of content that we think might be engaging for the users. A lot of folks are on their phones, on their mobile devices a lot, so we also use push notifications as a way to reach out to our users. And finally, in some situations, we actually do need to reach our users in a very timely manner. So we also take advantage of things like SMS to send really relevant information like, hey, here's your verification code, and this is how you can sign into the account. If you look at what's outside of these kind of outbound channels, inside the app itself, either on TV or on the mobile devices, we also have a center where we have all kinds of notifications that we deliver to our user. And so you can see this example of a little badge at the bottom, and that's where we have a list of past notifications and current notifications that we want to deliver to the user. And sometimes it even shows up as a pop-up on the tablet if it's a really key piece of information that we need to address right away. And so all of these are essentially orchestrated by a single system, and we can think of it as a message management system where we can manage a very large variety of message types. So I just want to show a few quick examples of how they might look like. So the first one is an example of some recommendations we might have for a user. The second is an example where perhaps we'll have a new title that is coming into our catalog or a new piece of original content that we produce, and we want to make sure that our members are aware of that. Perhaps you have a favorite show. If there's a new season that has just arrived, we would ping our members about a new season arrival that they might find relevant. And finally, we provide some sneak previews of content as well. So, send a ping to our users. Hey, clear your weekend. Here's a show that you might want to make sure that you watch on a Saturday night. And so we have a lot of different message types. These are just a very small sample of what they look like. And at the core of it is we need to have a system that orchestrates and send these to different channels, but most importantly, also make a decision on what to send and when to send to the user. So if you think about how to do that, a really simple approach would be to create some sort of decision engine where you might create a number of heuristics that say something like, if you have watched Stranger Things season 1, then most likely you're going to enjoy Stranger Things season 2. But if we already sent you something similar in the past few days, let's not send that to you again so we don't create clutter in someone's email box, for example. So that's a really simple approach. But you can imagine that over time, this can become unruly. It can become really difficult to manage. And so a smarter way to approach this is obviously to drive the decision engine with some sort of machine learning based approach such that the system can actually, from past observations, figure out what sort of messages to send to whom and when and how often. And hopefully this is a system that will sustain itself and learn over time. And that's exactly what I want to take everyone through today. So let's kind of think through what it would take to create a system like that. So first of all, we want to make sure that it is a personalized experience. So we want to make sure that we are making a decision for every single member differently according to what we know about the user. And we want to make sure that we deliver the most relevant messages to the users. We don't want to just send everything we have possible for the users. And another component that's important is that it has to be timely. So, a new piece of information or a new piece of title that has just arrived, we want to make sure that that is notified in a timely fashion. And we want to make sure that that is done at the right moment in time such that it will create the most joy for the member. And if you think about creating a system like this, if it's going to learn over time, effectively, we need to create a system that is able to mitigate as much bias in the data as possible so that when we learn the model is not just an outcome of what we've done in the past, but also the model is adapting to what's happening right now in the world. We want to maximize the impact of the system. And so if we want to maximize joy for our members, we want to make sure that every decision we make and every message we send is actually leading to someone actually enjoying a title. We don't want to send an email if we don't think that sending that email is going to lead to someone discovering a really interesting piece of new content. And finally, we have this tension between reward and cost. So the reward is that we want to have some sort of member satisfaction, but we cannot send an unlimited number of messages. We certainly do not want to be in a situation where we're sending push notifications to someone's phone every 10 minutes. And so there is some explicit and some implicit costs that we do need to consider when we are designing such a system. So let's talk through each of these components separately. So in order to personalize the messaging decision, we can think of it as effectively trying to optimize the outcome, which in this case is member satisfaction. And we can do that by effectively learning a model that will either predict a binary variable of whether or not someone's enjoyed their service, and there are many ways of representing that, or continuous amount of that represents how much someone has enjoyed the service. And we can create a model using a number of features that is specific to a user in order to create a personalized experience. So we might use information like which country the user is in. We might use information like what sort of past engagement behavior they might have with Netflix to learn about their preferences. We might even use information like time of day, day of week, to give us that additional time context so that we can make a prediction a little bit better. So this boils down to training a model, either a classification model or a regression model that estimates the probability that someone is going to enjoy our service at a certain time of day, but all the information that we know about the user. And there are a variety of techniques to do that. There's a lot of linear techniques, regressions, tree-based models, neural networks, and depending on how much nonlinear effects we want to capture in the model, there are some better choices than the others. So this is a pretty simple framework, and we can certainly do that. But we talked about the second component, which is that we don't just train a model and be done. This is a living system, it's an evolving system. So we want to actually make sure that we create a sustainable system where we continuously have a stream of data that is unbiased, such that we can train on it and we can continuously update this model. And so let's talk about what are some ways to think about how we might remove bias from the system. So when we talk about bias, a lot of people think about exploit. And so the idea is really that while we want to exploit as much as possible what we know about the users and what we can learn from that and create the best decision to recommend the messages for the user, we want to also reserve a little bit of a portion of the data we have for learning, right? And so that comes at a cost to our exploitation in the sense that we will not necessarily be making the optimal decision if we are learning. However, that will give us a source of data that would be as unbiased as possible. So there are a lot of commonly used techniques for that. The simplest is the epsilon greedy, where you basically say for X% of the time, we're going to make a random decision. So in our case, let's map it back to the messaging problem. For X% of the time, we're going to send some combination of messages at a certain point of time. And we're going to learn what happens when we do that. So what does the member do? How do they react to that when we send that certain combinations of messages? And then for some other time, we're actually going to make a smart decision. We're actually going to use everything we know at the moment and try to make a best decision, for example, by using the model that we've learned to determine what combination of messages we will want to send to our user. And there are also techniques like the upper confidence interval, where we can effectively take advantage of the uncertainty that we can estimate of the different combinations of messages that we can potentially send to the users, and choose a combination such that it has the highest confidence bound, meaning that we potentially know the least about it, but also it's optimistic and learn about what happens when we make that decision. And finally, there is techniques like Thompson sampling, where we can construct a posterior distribution and basically sample from that. And so sample from the likelihood and figure out what happens when we send a specific sample sampled from this posterior distribution, and with that message combination, what we can learn. And so all these are common techniques, and that provides us a constant stream of data that is relatively debiased, so that we can make sure that our model is really not just a product of its own outcome. And so kind of to give a very specific example of how that might look like, if we, let's say, take epsilon greedy as the method of choice for explore exploit, then what we could effectively do is for some percent of the time, we're going to choose a random message or a random combination of messages and send that to the users. And for some other percentage of the time, we're going to look at information we have about the user, such as country, past behavior, some sort of like day of week, time of day context, and then make a best decision using the model that we trained earlier, and then determine what combination of messages we might send to the users. And a lot of you might recognize that this is essentially a very simple contextual bandit setup where we take advantage of this explore exploit paradigm, but at the same time, in the exploit arm, we are able to incorporate information we know and try to make a best decision in the face of a little bit of uncertainty. And there are a lot of other debiasing techniques as well. Some of them take advantage of the fact that we can try to upsample training data where we have the least amount of knowledge on. And so without going into detail, we can essentially estimate propensities of certain combinations of messages, and we can reweight our training data if the occurrence of those actions is very rare. Or alternatively, we can choose to inject a little bit of a noise. And so we can inject a little bit of a noise to the policy that we feel relatively confident about and observe the outcome and use that as a way to debias the data that we have. And so when we're talking about these techniques, it's going to be hard to really decouple that from the concept of causality, right? So to put it really simply, we really want to answer a question of, if a subscriber come and visit Netflix and they watch a movie, is it because the message we sent was really relevant and it was really helpful, or that, they would have come anyway and they would have come watch a show and enjoy a TV show anyway, even if we did not reach out, right? Is the message really, really driving that additional enjoyment from our member? And that's a really key question we want to ask because, again, we don't want to send a message to a user if we don't truly believe that it's going to bring that additional enjoyment. We're not going to help them find the relevant content that they might enjoy. And so I want to talk a little bit about how we might maximize the causal impact of the system we built. And so, we talked a little bit earlier about building a model that tries to estimate the probability that someone would enjoy our service or estimate how much they might enjoy the service using user and time and additional context. That model really is only correlational, right? So we are constructing it from our past observations, and that only captures that correlational aspect of those relationships. But remember that every observation or every row of data we have is really influenced by past actions from our messaging system. And so we want to make sure that we incorporate it. And so in this case, when we're estimating the probability that someone would enjoy our service, given all the user features we have, what we could really do is to model it as the probability that someone is going to enjoy our service, given that all the information we have about the users and time of days and additional context, and that we have sent them a certain combinations of messages in the past. And so this context that we're adding here, which is the past personalized decision-making that we want to incorporate into the model, is essentially going to help us control for that final probability. Is going to help us add a causal component to what we're estimating here. And so a really simple way to think about how we might use it is if we estimate that someone is going to enjoy our service by being someone in the US, having watched a lot of shows in the past, and have also been sent an email about Stranger Things coming, season 2 coming. If we think that propensity is going to be a lot higher than, for example, the same person not having been sent with that exact same message, then we think that it's worth it to send a message. So another way to say this is we really want to make sure that there is a lot of incrementality in the likelihood that someone is going to enjoy our service by receiving an email versus not receiving an email. And that incrementality is really the crux of a lot of what we do here. We want to make sure that that is maximized such that the decision we make for the users is causal. We can do that, and that would make for a pretty great policy where we effectively only send a message if the incrementality of someone enjoying our service is high. But if we do that, you can still imagine a world where there's always going to be a little bit of incrementality increase when we send a message, because let's face it, we all like to, mindlessly click through our phone sometimes and swipe through, content and recommendations that are given to us, but is more really better. And in this case, we actually firmly believe that we do not want to send an amount of messages to a user that is unbounded. And so we really want to think of this as, hey, we want to impose a volume constraint on the amount of messages we're willing to send to our user. We want to be very judicious with our decision, and we are only willing to send a message when we think that is going to lead to a very large amount of enjoyment of our member. And so a few different ways of doing it. A simplest way of doing it is really just to determine some sort of threshold for the incrementality. And so we would only send an additional message if we think that that additional message is some amount more incremental than what would have sent so far. And now, of course, tuning what that threshold is going to be tricky, but there are a lot of different ways of thinking about it, and it would incorporate equal parts science as well as equal parts sort of like product vision in this case. And there are also a lot of different flavors of reinforcement learning in the recent years, very active areas of research where folks are trying to say, hey, we are treating this as a bandit problem where we actually have a budget constraint. And so in the ad space, for example, this is a very common problem. In our case, our budget constraint is effectively how much messages we're willing to send. And so that's another way a really good way of framing this problem. So let's take the really simple example of setting an incrementality threshold. If we put it back together with kind of what we worked out earlier, again, we can use something like epsilon greedy algorithm to do a really simple explore-exploit. In the explore arm, again, we randomly sample from frequencies and candidate message distributions to determine what combination of messages to send. And then in the exploit arm, we can now use the model we constructed with the causal component, where we basically have estimates for if we are to send a message versus if we are not to send a message, and then additional layers on top of that to estimate the incrementality of sending a specific message at a given time. And then our policy will basically greedily assemble the set of messages to send, subject to some predefined incrementality threshold. And so we would keep sending until we determine that the next message is really not going to drive any material member enjoyment anymore, and we would stop at that point. If we have a setup like this, we really want to make sure that we have some sort of offline evaluations available before we take it online. And so this is an example that someone might use in something like a replay offline evaluation. So let's say we have 6 different users. we can look at our Explore policy and gather all the reward that we can collect from all these data. And then we might have a policy that we want to evaluate at that given moment. And the way we can evaluate it is effectively go through every single entry of the data that we collected from the policy that we're trying to evaluate and match it back to the Explore policy. And if we have a match in the exact same actions we've taken, so in this case, it would be the exact same combinations of emails we send, then we can collect the reward. But if there is not a match, then we do not. And so by doing that, we can effectively replay our policy and get a count or an estimate of how well a given policy that we're trying to evaluate perform relative to the observations we've had in the past. And finally, most importantly, we want to take this online. And so we always run A/B tests on all of these personalized experience. And A/B test is still the final oracle in terms of helping us understand what long-term behavior and impact of a given policy or a given algorithm is. And so we have, in fact, taken some of these variants that we talked about online in production, and I just want to quickly show a chart where we have a non-personalized variant represented in green, where the x-axis is how many emails or messages someone may receive on a given week. And then the y-axis is the density or the count of that. You can see that for a non-personalized algorithm, it is clustered very closely around some number, because it's unpersonalized, most people will effectively receive a similar amount of messages, versus when we try out a few of these different techniques I mentioned and create a personalized experience, we effectively have a more spread out distribution, meaning that for folks who we believe is going to respond and enjoy the messages we send to them more, we would send more, versus for folks who really were not going to enjoy that, we make sure that we do not send them messages that are not useful, and we are very careful and judicious in the amount and types of emails we send. So to recap, we chatted about sort of like a framework to think about how we might construct a personalized messaging system. We want to make sure that it's personalized and timely. We want to make sure that the system is sustainable and is free of bias as much as possible over time. We want to make sure that it's very impactful, especially from a causal standpoint. And we want to make sure that we're balancing the amount of messages we send with that final volume, because we want to make sure every single message we send is impactful and is actually truly relevant and useful for our member. And in fact, all these requirements and principles really apply to any personalized systems. And there's really a lot of exciting future work in this area, both in the messaging space specifically, but also in this general area as well. You can check out more in this link to a paper that we've had with a lot more detail here. But I hope this is like a interesting introduction to a framework for how we might think about tackling personalization problems specifically in the messaging space. So finally, I just want to say this is work that is done by a lot of folks on the team, a lot of scientists and engineers for many years. I'm merely here to represent them, and as well as a lot of really great work by our cross-functional partners. And so I want to thank them for their work, and I want to thank everyone here today for spending the time with us.